all of you, this is MathDoctor, and let's begin with the new concept of probability independent events. It's MathDoctor. In this lecture, I'm going to explain you about what are independent events. So let's look at the example we have choose in our 52 cards. We have given the 52 cards, and in that we have first taken, we have defined two events that are E and F. It knows the spade. We have further divided cards into four. One is spade, another is diamond, and one is club, and another is heart. So this is the spade, which is the one of the category of 52 cards. And again, we are going to choose the event such that it does not have any condition with the previous one. So if we have taken the spade, then we are going to choose even bricks or heart. Then it has a relationship between that category, because it also contains in that category of 13 of cards. So if we look at the another categories, that is which has no relationship with them, we are going to take ace. So we have not defined here, is it ace from spades, either from heart, because we have four different types of aces present in the whole card. So we're going to look at the probability of finding F also. So in the earlier classes we have discussed, if we have to find the probability of events such that it occurs simultaneously, then we use our multiplication theorem. So in this independent events concept, so what we are going to choose, we're going to choose multiplication theorem, and we're going to apply it multiplication theorem, and we can modify it as our independent event. So how independent event exists actually? So in this example, we're going to choose, we know that by choosing ace, we don't define any relationship between spades or these four categories. Is this ace from heart? Is this ace from spade? We have not defined, but we know its probability. It's either from these four, which is 1 by 4. So we know that its probability of F is 1 by 4. And probability of E, we know that 52 cards are divided into four categories, four different categories, each including 13. So we know that it's also 1 by 4. So that's the idea. But we have four categories, but each category has 13 cards. So we have here defined here, and four different cards are present in each category. So we have written here 1 divided by 13. So in order to see here probability of F from this whole 52 cards, what is the probability that from whole cards we have given 52 cards, and we have to find any four aces. We don't have any relationship between spades and ace. So this is the one of the problem which we have discussed in order to get to understand our concept of independent events. So how independent event exists and how we use it in solving our different types of theorems. And also we're going to look at to modify our multiplication theorem more in order to get for separately our independent events. So this is the probability for finding F, for finding ace, and this is the probability for finding spades. So we're going to now see that. So we're going to see probability of finding both E and F. So if E is already occurred, E is denotes we have taken out spades, and then we have to also E is already happened. This is also true, and but in the independent events we use this formula because we know that it is independent. So in independent events, this if because there is no relationship between both of them, we can find out the probability of this in a three different ways. Probability of E and F, where when both are occurred. So it denotes as space and it's known that is. So we're going to just look at simply what's the in first method we're going to see. We know that there is no any card which is repeated many times in a card. So if we have spade and also ace, so it must be one card which is present in the whole card. So we're going to want to see another type of card which is ace and already spade. We're going to see one is ace, one is heart, and another types of cards. We're going to look at the whole our cards which we have taken. So in this by applying the simple probability method, we're going to choose by just knowing its by understanding that what's the probability we are going to find by understanding its common part, and we're going to take that it has only one there is exist by using this methodology. But we're going to look at the how to apply our conditional how to reach our answer by using this these formulas of multiplication theorem. And by using multiplication theorem we know that, so by also using probability of E and F, so then we can also find in this particular problem we can also reach to our answer by just know that what's the probability of E, and we know probability of E is nothing but 13.52, and it is nothing but from whole 52 we have just 4, and that's the idea about. So 52 which is again 1 by 52, which matches with our, when we put it here, 13 by 52, and also because E has already occurred, now we're going to confine our answer to only 13 events because we have already occurred E. So we're going to choose F events which is denoted as ace. So E spades has already occurred, so we'll jump into spades, but ace has the, we are going to find its probability, again find its probability because we have choose spade. So here it has no relationship, any condition does not apply. So condition applied because we have also find its probability. So what's the probability that it is in spade? Then we are going to find. We have not given that it is in spade. So here that's why, that is the reason we are going to choose this formula. Our for finding probability of F, we're going to write first probability of E. So in independence event, so we are going to choose the probability of F. What's the probability of F, which is we know that which is 1 from this whole 13 cards. So we're going to know that it is also 1 by 52. So by using these two formulas we come to conclusion that if condition is not satisfied, this is our final conclusion from independent event. So when we use this sign of condition, we're going to just cut it and just remaining we're going to separate its remaining part, and we're going to use only F except F such that condition applied of E. So we're going to again look at this. This will be equals to this. So we know that this is equals to that. So by using these conditions, so this is how we introduce the concept of independent events. So independent events exist when we're going to also look at the three conditions. When we met with three conditions, then it must have to be we must have to note its condition first of all. So let's look at the three conditions. What are three conditions? for three events, what are the conditions we met with? So for probability of finding three events held simultaneously one after another at the same time, and we're going to find its probability. So we know that its probability is nothing but when we apply our conditional. So it becomes very easy, convenient when we write it in a independent event. So that's why we have introduced the formula of independent events. So we're going to see that because E had already occurred, so then we can also find the probability of G. So this method is very much difficult or lengthy for finding our quotient. So that's why we have introduced the fact that we have to separate this condition, and we have to just put it out from the whole probability. So that's our final answer of finding this probability when every element exists, very event exists simultaneously. So this is how we come to our conclusion. But also it should be implied that here for writing this into that, we know that E and F should be E and F, because we know that this should be equals to that we have already written here PF. So this could be written as that. But how we can write this as a that? So we know that f of e is that. So g of e should be g of e. We can also write it in such a way that first of all we could count that, and because our answer should be arrived with both methods, so we can also diverge this into one form, and then just put it from the bracket, then we can find our probability of G, which is written here. So we're going to look at the probability of GE and probability of FE. So these conditions should be met. Okay. These conditions should be met. So probability of G. So these are the events which is known as mutually exclusive events, mutually independent events also. So these should be considered in mind. The concept of dependent events and mutually exclusive events. So when we have no condition with any event, either it's E, either it's G, so it is known as independent event. So let's look at again these conditions, how these conditions should be met, then we can find this conclusion. Because to combine this, to get from this whole conditional probability to independent G probability of G, we can see that by merging this into G, we can also again merge into G. So, but this is the not only way. We can also merge first of all this into only F, G and F. Then we can come to our conclusion G. So these are the 2 points. One is F of E should be F, so which we have written here, and another is G of F should be G. So these are the conditions, and also this is the condition which we have mentioned here. So we're going to just put condition from the probability out from the, we're going to separate it, separate that condition from the probability, and then we're going to write in such a way that in that way we can easily get to our answer. So this is how our independent event works. So this is how my lecture. So I hope you will enjoy my lecture. Thank you to all of you.